or. See those two given numbers? Factors of 12, so I can have square root of 6 times factors of 12, square root of 6 times square root of 2. And since they are exactly the same, take it out from the radical, will give you just 6, bring down square root of 2. Same answer. When we simplify one factor to the other. Example 2. 3 square root of 5 times 2 square root of 4. Multiply the numbers outside and multiply the numbers that are in radicals. So 2 times 3 will give you 6. Square root of 5 times square root of 4 will give you square root of 20, which again can be simplified as square root of 4 times 5, which will go out as 2, will remain as 5. Then you multiply with 6. So your final answer will be 12 square root of 5. So when you're looking at numbers, you could simplify either way or what you're working with the numbers. Okay, example 3. 4 square root of 8 times 3 square root of 5. Just like what we did earlier, the coefficient to the coefficient, square root to the square root. Four times 3 will give you 12. 8 times 5 will still be inside the radical 40. But again, 40 has a perfect square number. So again, factor this out, which is square root of 4 times square root of 10. Always remember, one perfect square number. And I've shown you what are the perfect square number. Square root of 4 is outside the radical. Bring down square root of 10. Bring down your 12. So 12 times 2 will give you 24. Square root of 10. This is now your answer. So going back and forth, if they're exactly the same, we just take it out from the common or the radical symbol and leave the radical by itself. Okay, that's simplifying. The last part that I'm trying to review, which is useful when you go back and look at special right triangle. The one that I'm working on, the lastly, is rationalizing the denominator. When we talk about rationalizing the denominator, we will not have a radical on the denominator. Means to say, no radicals on the denominator. No radicals on the denominator. So please be aware on how you're going to work on this one. Because as you can see, or if some of you already have loaded and look at the videos on special right triangle, this is essential. So you can go back and forth. Alright, example 1. Square root of 3 over square root of 5. Square root of 5 is on the denominator. This is your numerator. This is your denominator. And you have the fractional bar. So in order for us to simplify this, let me rewrite it again. Square root of 3 over square root of 5. Whatever is the denominator, you have to get rid of that. When we say rationalize, multiply. Whatever is on the denominator. Square root of 5 over square root of 5. So when you multiply square root of 5, because that is what is on the denominator. So look at what's on the denominator. If that is the denominator, that's the one I'm trying to multiply to both the numerator and denominator. And then, just like what we did earlier, when we multiply numerator, multiply denominator. Square root of 3 times square root of 5 will give you square root of 15 over square root of 5 times square root of 5, which will give you square root of 25, which is just simply 5. No more radical on the denominator. This is now your answer. See that? So if you have the same number that you're multiplying, just remove the radical symbol and write what is the common number. You don't have to do this, because if you're going to multiply, it give you 25, and the square root of 25 is 5. So if they're the same number, just take out what is common without the radicals. Be aware about that. Okay? All right, example 2. 2 square root of 3 over square root of 2. 2 square root of 3 over square root of 2. Let me rewrite that so you can follow. 2 square root of 3 over square root of 2. I rationalize. Multiply by whatever is on the denominator. Square root of 2 over square root of 2. I only multiply the ones that have the same radicals. I copy down 2. 3 times 2, square root of 3 times square root of 2 will give me square root of 6 over common. And again, if I'm going to write it down earlier, that's square root of 4, and square root of 4 will just give you a 2. Since I have a 2 on the numerator and a 2 on the denominator, I need to simplify this. 2 divided by 2 will give me a 1. So your final answer is just radical 6. Look at the difference. So if looking at the numbers. All right. Example 3. I'm just more onto 2. Square root of 5 over 2 square root of 3. Again, let me rewrite that one again, because that is my original problem. And you can see what I did. Rewriting square root of 5 over 2 square root of 3. I only multiply whatever is the radical. Do not include the 2. 2 is not in radical form. So in this case, I only multiply it by square root of 3 over square root of 3. So be aware, whatever is the radical on the denominator, that's only what I'm going to multiply. Now it will give me square root of 5 and square root of 3, square root of 15 over. This one will give me 3 times 3 will give me square root of 9, which is equal to 3. So, but I have a 2. Multiply it by 3. So the denominator becomes 6. No more radicals on the denominator. This is my answer. Okay? All right, the last one. So you have to follow and review on this one. 6 radical 6 over radical 3. Again, let me rewrite it again. 6 radical 6 over radical 3. I rationalize, multiply by radical 3 over radical 3. Multiply 6 and radical 3 will give you 6. Radical 18 over 3 times 3 will give me 9. Square root of 9 is 3. But oops! Square root of 18 can still be simplified, which has a factor of square root of 9 times square root of 2. Square root of 9 is 3. Square root of 2. So multiply 6 and 3. So your final answer will be 18 radical 2 over 3. Is that my final answer? Oops, no. Divide 18 and 3. So your final answer will be 6 square root of 2. That is the answer that you're having. All right? So hopefully this will help you on the problems that you're going to work on later on with special right triangles. And for my